Didn't see you there. Welcome to another exciting edition of K-Ride the Science Guy. Today we've got a great topic for you. Glycogen synthesis and breakdown. Enjoy. So folks, we're going to start off with glycogen breakdown. Now, glycogen breakdown converts to glucose, which goes through the process of glycolysis, which happens in the cytoplasm, which will produce 2 pyruvic acids and 2 net ATP.
Here we got a glucose being ripped in half. 2 pyruvic acids and 2 ATPs come rushing up. These ATPs are excited, full of energy. Look at those orange little buggers.
Now, the pyruvic acid we just made from glycolysis binds with coenzyme A to produce acetyl-CoA. This acetyl-CoA enters the Krebs cycle, also known as the citric acid cycle, which occurs in the mitochondria. In order for this to operate, you need an NAD+ and an FAD. As it goes around the cycle, we produce 1 ATP, an NADH, FADH2, and 2 CO2s. This NADH and FADH2 carry electrons to the electron transport chain, but we'll talk about that later. As the acetyl-CoA continues around the cycle, it gets regenerated.
During the Krebs cycle, NAD+ and FAD get reduced by receiving electrons, here represented by ping pong balls. The NAD gets 1 electron and becomes NADH, while FAD receives 2 electrons and becomes FADH2. Also during the Krebs cycle, ATP and 2 CO2 will be produced.
Now we're on to the electron transport chain, which starts with FADH2 and NADH, which carry the electrons over. Now, these electrons are dropped off on mitochondrial inner membrane proteins which contain iron. This produces hydrogen plus ions, which are pumped outside into the inner membrane space. Hydrogen ions then diffuse back into the mitochondrial matrix by passing through ATP synthase, which generates ATP. And the net result of this is 32 ATP per 1 glucose.
The NADH and the FADH2 carry electrons from the Krebs cycle to the mitochondrial inner membrane. These electrons are transported through the electron transport chain, which is made up of membrane proteins that contain iron, and they ultimately land on an oxygen molecule. As these electrons are passing through the electron transport chain, hydrogen ions are being pumped from the mitochondrial matrix to the inner membrane space, creating a hydrogen plus gradient.
The kisses of the sun were sweet, I didn't blink, I let it in my eyes. Like an exotic drink, the radio playing songs that I have never heard, I don't know what to say. Oh, not another word, just silent.
Hydrogen plus goes from a high concentration in the inner membrane space through ATP synthase to a low concentration in the mitochondrial matrix. As this happens, ATP synthase produces ATP. These hydrogen plus end up binding to an oxygen atom, which previously captured electrons from the electron transport chain, producing H2O, also known as water.
Now we're on to glycogen synthesis. This is when your body has an excess of chemical energy. It synthesizes glycogen. Glucose travels into the cell and is converted to glucose 6-phosphate via hexokinase. The glucose 6-phosphate is then converted to glucose 1-phosphate. With the help of glycogen synthase, this molecule loses a phosphate to become glycogen, which is then stored in the cell until it needs energy later.
When glucose travels into the cell, the enzyme hexokinase converts it into glucose 6-phosphate, which interestingly is unable to travel back through the cell membrane to leave the cell. Glucose 6-phosphate eventually becomes glucose 1-phosphate, which is then converted to glycogen when the enzyme glycogen synthase helps strip off a phosphate.
Well, kids, thank you for joining me in this week's episode of K-Ride the Science Guy. Stay tuned next week for Einstein's theory of relativity. Enjoy.
This has been a Red Shoe production.